This one's going to take a little bit longer because I got to
In order to simulate an ocean-going freighter's weight, they're working on reproducing the exact properties of a 500-foot freighter with a loaded weight of 7,000 tons.
Remember last time we had to wait? Look.
Last time they tested the grid, Phil was pumping 6% air into the water.
That's only one. Now watch with two on. Here she goes.
This time, he's pumping 25%, which should represent a large gas eruption. Bruce is now confident this is enough to sink the boat. Phil is marking up the boat so they can monitor how low it will sink in the bubbles. If Phil is right, a freighter would only have to enter a small part of a gas eruption for the result to be catastrophic.
And I think, you know, a flume of 300,000, 400,000 cubic feet of gas coming up from the bottom. I don't care if it's one big bubble or a billion little bubbles. It's a hole in the water.
Turn them on. Yeah. Come on. It's a very turbulent situation, so the boat's bobbing up and down, but there's a definite loss of buoyancy.
With 25% air in the water, the boat should have sunk. However, there is something they haven't anticipated.
It's not dropping very much. That's not a good sign. The bubbles themselves lower the density, makes it sink, but the upward force due to the flow of the water is keeping the boat up. It looks like the two roughly cancel each other. Yeah, come on over.
Bruce had not expected the neutralizing effect in the center of the bubble field. Time is running out, and there is only one more thing he can try. The lifting effect of the upwelling water in the center is keeping the boat afloat. By moving the boat to the edge of the bubble field, where the upwelling is far weaker, the boat should sink.
So boom, she drops instantly. See that? Instant drop. Okay, that should lift the front. There she goes.
Come on.
There she goes. She's going to go.
There we go. Is it going?
Yeah, she's going because what's happened is the front's more buoyant than the back.
Looking good.
Remember I said if you were a 500-foot boat and your 200-foot would have hit one of these things and your back 300-foot weren't, your boat would just snap in half and sink instantly. Instantly. What's happening is the front is lifting and the stern is dropping because the front is in more dense water than the stern.
Come on.
30 seconds she's got. Time me.
It's looking real good.
Nope, she's going.
It's
She's
going.
gone.
That's
She's
it.
gone. Bye-bye. Bye-bye.
They've done it. Gas bubbles really can sink ships.
Okay, let's back this boat into it.